Pressure only affects for gaseous reactants and products. If not, you can say pressure affects only for reversible reactions involving gases. Only for the reactions involving gases. Reversible reactions involving gases. At a given temperature, pressure of a gaseous mixture depends on the number of gas molecules in a given volume. Therefore, pressure of a gaseous mixture can be reduced by increase in the volume and can be increased by increasing the volume. Yeah, can be increased by reducing the volume. And is that clear?
So the incomplete can be negative. What?
And also pressure
and also pressure
at which the reaction is carried out can be increased by using more moles of the reactants in the same volume. That means adding more gas. As here, adding more reactant will increase the pressure.
Okay. That's it.
Increase in the pressure
favors the side with less number of gas molecules.
yes, favors the position of equilibrium. You have done this in the earlier stage.
Yeah.
To the side with less number of gas molecules, or fewer number of gas molecules.
So the pressure favors
To the side with fewer number of gas molecules. Not finished. One more table is there for you to go. Yeah, copy this table, please.
so fever number.
Sorry?
So what did you say after fever number?
Fewer number of gas molecules. Oh, and you can copy this table. This table, please. I have already shown it. Where's your spectacles?
Enlarge.
Yeah, enlarge. Inversion. Enough, no, the enlargement. So here I have example as well. So this one shows that left hand side has 4 gas molecules, right hand side 2. Here left hand to right hand one. I2. I2 and H2 2HM. Hello. Hare. Massage only 1 hour 5,000. Oh. Finish, right?
No.
Morning. Morning means name of morning means from today 12 a.m. to
Sorry. Disconnected. I don't know what is the reason. Okay. So the next one then.
effect of changing temperature.
Next one is then effect of changing temperature.
Oh, we know.
Next topic. Effect of changing temperature. Ita mati හැබැයි ලියන්න නම්.
උත්තර දෙන්න.
If the temperature of an equilibrium, yes. If the temperature of an equilibrium mixture is raised, the rates of both forward and backward reactions will increase. However, the increasing the increase in the rate of endothermic reaction endothermic reaction right
Reaction.
endothermic reaction will be greater than the
Exothermic reaction.
increase in the rate of
Endothermic reaction will be
Than the increase in the reaction. No?
exothermic reaction in the rate of reaction of exothermic reaction.
However, increasing the rate of endothermic reaction will be greater than increasing the rate of the reaction.
Now, when you increase the temperature, rate of both forward and backward reaction will increase. But rate of increase in the endothermic reaction will be greater than the rate of increase in the exothermic reaction.
So some of both will increase.
Right? What is which have the great effect? Endothermic side.
Endothermic.
Right. And therefore, the position of equilibrium will shift to the endothermic direction.
Endothermic direction.
Endothermic direction.
Direction, not reaction.
Yes. Increasing temperature favors the sonadic portion of the equilibrium to the endothermic side. Decrease in the temperature favors to the exothermic side.
Backward or forward.
If you have enough
Space.
space, you can write this one.
Table.
Oh.
Don't tell me. Table. See the table?
එකම දේ තමයි තියෙන්නේ.
එහෙනම් ඕනේ.
මේ දෙක ලියාගත්තොත් කැමති නම් හතරම ලියාගන්න. Nothing to write. Yes, yes. Make with alien.
He's asking nothing to write and taking a photo.
Mm.
So you should write that simple lie, right?
Hmm?
Increase.
No.
So then it's going to
Asking for the print that.
photo again.
Are I got that? Hey, Lian.
What?
Why are you waiting? Are you attending?
I look like my area is smaller than and
Who's happening now?
You get an end and come back.
yeah. Don't always try to make fun.
Then it is.
Writing you can do.
Yeah.
Okay, next one then. Effect of adding catalyst. So what is the effect of adding catalyst on rate?
Whatever. Equally. Therefore, the
Yes. Write down. Catalyst will increase the should I increase the rate of both forward and backward reactions equally. equally. Rates of both forward and backward reactions equally.
Okay.
Therefore, position of equilibrium is not altered.
Okay, that's it.
So can you repeat?
Given? Yes.
Position of it.
So the position of equilibrium is not altered. Okay? No? Or you want from the beginning. Catalyst will increase the rate of both forward and backward reactions equally. Therefore, the position of equilibrium is not altered.
I have my class.
How is it? Okay. But the position of equilibrium will reach sooner. මොකද මම ඊට
Adding the catalyst at the beginning of the reaction.
ඊට පස්සේ adding the catalyst.
Yes,
Yeah,
yes.
adding the catalyst.
But position.
Then Eva pass.
Because this is
Adding the catalyst.
So after all the
Yeah,
Yes,
yeah.
yes.
Adding the catalyst in the beginning of the reaction.
We'll reach the equilibrium sooner.
Will cause the equilibrium to be achieved fast.
We'll reach the equilibrium sooner.
That will be.
හරි නේද?
Hey, tell to change that.
We'll reach the equilibrium sooner.
I should be then here among the one the negative line to another thing.
Next one, limitations of making qualitative predictions. Limitations.
What?
The limitations can be made. Okay. Now let's take example. 2NO2 reversible N2O4. Delta H is minus 57.2. Now in this reaction, what happens if you increase the pressure? What happens if you increase the pressure? What happens if you increase the pressure? Which side? Thing on my left side 2 gas molecule, right hand side 1 gas molecule. N2O4. My pathria. Right. Now what happens if you increase the temperature?
Backward. Backward is fast.
Now which effect is greater?
Backward.
Home again, back end, back end.
the association.
Right, okay.
Why did you say yes, teacher?
Because he typed I.
Now,
replied
Raman,
different
so this reaction is important, right? So when you increase the pressure, position of the equilibrium favors to the right hand side. Make a body this is brown color and this is colorless.
So the color.
You can observe the color. So if you increase the pressure, what is the observed color? Where is it?
Brown.
No, not brown. Yes. Pink? Yeah, piece of it.
Yellow?
It become pale brown.
Okay. Yellow.
Hey, pale brown?
Then what about colorless?
Colorless when? Because NO2 will make N2O4, yes, but not all the NO2 will goes to N2O4. So some NO2 remains. Therefore, it won't go to colorless. Eshan, what is the color change? Can I have that one, please? Yeah. Yes. What is the color change? No. Here, this side you have NO2, two NO2 molecules. Here you have N2O4. Number of atoms are same, but the number of molecules are different. Therefore, increasing the pressure favors to the side with less number of gas molecules. So the brown color will goes to the colorless side, but not all the NO2 molecules forms N2O4. Therefore, color become pale brown. And then when you increase the temperature, what will happen? Portion of the equilibrium will favor to the left hand side. It become dark blue. Which effect is greater? We can't predict unless we have done this. No, we can't. Okay. First write the equation with the conditions. Sorry. Write down. Okay. Increase in the temperature favors the position of equilibrium to the left hand side because the forward reaction is exothermic. Because the forward reaction is exothermic. Because the forward reaction is exothermic. Therefore, the color darkens. Therefore, the color darkens. However, when increasing the pressure, favors the position of equilibrium to the right hand side, as there are fewer number of gas molecules present.
Can we from how you are getting in increasing the pressure?
Position of equilibrium to the right hand side, as there are fewer molecules. Therefore, the color becomes pale. Don't write colorless.
Yeah, because for that side of the
Only there are few.
Pale.
I think that happens because like both reactions happen.
Both the reactants are there. Next point, we do not know which effect is greater. We do not know which effect is greater.
Sir,
So-
could you repeat that?
We do not know which effect is greater. We do not know which effect is greater. So we cannot predict the position of equilibrium if this reaction is carried out.
So we cannot.
Predict the position of equilibrium
In the laboratory.
position of equilibrium.
In a nightclub. In nothing. In this
If this reaction is carried out at
room temperature. Room
high temperature and high pressure. Position of equilibrium if this reaction is carried out at high temperature and high pressure. High temperature and high pressure. Right. Right. Hadi. එකත් ඉවරයි. එතකොට there will be a problem. Hadi. We'll go for some questions now. Page number Page number 251. Checkpoint 1, 2, 3, 4. Okay, first we'll do checkpoint 1 and 2. Yes.
Page number, what did you say? 2 weeks.
So 51 is.
Ask his son, he's the one who's speaking the time. What time is it? And he won't say it. Yeah. Training time.
Not included. I'm coming to that class. Don't ask.
So where are we getting?
Nothing.
Okay. Amagi, what is the answer for the part A? Predict the effect on position of equilibrium of increase in the temperature and justify your answer. What do you think?
There is no effect.
No change. Yes, very good. Because delta H is 0. Therefore, temperature has no effect. Suggest why the reaction mixture is heated when used to prepare ethylethanoate. So, Nadi, even though temperature has no effect, why the reaction mixture is heated?
So then the reaction takes
Simi. Ramesh, what do you think?
the rate of reaction increase
Asia?
because of the collision rate increase. Successful collisions. No.
To overcome the activation events. Heating will increase the rate of reaction. That also you can say that's okay, but the correct answer will yes to overcome the activation event. Okay. Sulakshana, second one. Still doing. When carbon dioxide dissolves in water, it forms a solution containing some carbonic acid. Carbon dioxide is less soluble in hot water than in cold water. Carbon dioxide is less soluble in hot water than in cold water. So in cold water it is more soluble. In hot water it is less soluble. So the forward reaction is negative or positive. Sulakshana, what do you think?
Negative.
Negative, positive.
Negative one because අනිත් පැත්තට heat එක
So Heshan, what do you think? What is your answer? Negative or positive? Huh? No answer. Tamesh? Huh? Negative. Negative. Now, in hot water, which side this reaction is favored? Right hand side or left hand side?
Left.
Why left side?
No.
No, why right?
Because
It is less soluble. So the soluble Heshan. Soluble means this reaction goes in this direction. The less soluble can it goes to this direction. Ne? So increasing temperature favors to the endothermic side. And it says more soluble in cold water. So as you decrease the temperature, this side favors. Therefore, the forward reaction is exothermic.
so negative. So what is the correct
Justification is at higher temperatures, as the temperature decreases, position of the equilibrium favors to the exothermic side. Of equilibrium favors to the exothermic side. Okay, now question number 3 and 4. A sample of insoluble solid led to chloride is shaken in some dilute acid and left until an equilibrium mixture containing some undissolved lead to chloride is established. State what would you be observed if the concentration HCl was added to the mixture. Justify your answer. Shenan, can you tell me the answer? Sample of insoluble solid lead to chloride is taken, some dilute and left until an equilibrium mixture containing some undissolved lead to chloride is established. What would be observed if the concentration of hydrochloric is added? Who answers? Yes. Sonali, what do you think? Not sure. Raksha, what is your answer?
Lead chloride dissolves.
Yeah, lead chloride dissolves. Yes. So the portion of the equilibrium favors to the right hand side. Hey, you are adding concentrated hydrochloric acid. Cl minus. So more Cl minus, portion of the equilibrium favors to the right hand side. So solid will dissolve. Not everything, but some of the lead chloride will dissolve, forming PbCl4 2 minus. Because you have added one of the reactant. Okay, right? No, Asia, what? May look at this. You are adding Cl minus. So the concentration of this increase. Hydrochloric acid, H plus and Cl. So more Cl minus is there. In order to reduce the added Cl minus, this goes to the this. Correct? Right. Position of the equilibrium favors to the right hand side. Therefore, some of the solid lead chloride will dissolve. Hmm. All right. Question number 4. A, B, C, D. A for Tamesh, B for Heshan, C for Sulakshana, and D for Halil. A for apple. Okay. No, you do it your own.
I could say we'll discuss now.
No. I'm let them to think and do the. Finish now? Okay, Tamesh, first one. Position of the equilibrium when the pressure is increased. Why? Why no change? Same number of gas. Heshan? Increase in pressure? Increase in pressure. Left or right? It's right. Unknown. Yes, right hand side. Reason you have 2 gas molecules in the right hand side, 3 gas molecules in the left hand side. increase in pressure favors to the side with less number of gas molecules. Sulakshana? Left hand side you have 2 gas molecules. Right hand side has 3 gas molecules. Gas molecules. Increasing the pressure favor to the side with less number of gas molecules. So to the left. Ali. Left hand side 9, right hand side 10. Yes, so left. So the answers, no change, right, left, left. Lesson में करता दिया रे भाई. Yes. Unit 1 ने कता दिया ना वही नहीं करें. Unit 2 we are doing most. Right. Right, okay. Moving on. Equilibrium in industry. Reversible reactions in industry. Your lesson is over. Lesson no. You have to write it again because that lesson is very important. Therefore, you have to write twice. Valid reasons, you know. Sorry? Oh, reversible reactions in industry. Write down. If I'm going to appoint you as a chemist in the industry, will you be going to do the reaction as a reversible reaction or like the reaction goes to the single direction only?
Goes to the single direction.
Hands up who are saying goes to the single direction. 1, 2. Let's say you are going to make ammonia, right? So if you are going to make ammonia, right? So are you planning to do it in a reversible reaction or that reaction goes to completion? Hands up who are saying goes to completion. 1, 2. Anika, come get reversible. Okay, why is it reversible? What is it? No, no. What again?
I ගන්න පුළුවන් පිටිපස්ස. And then why I said because then like අර එකම වෙලේට අනිත් පැත්තටත් වෙනවානේ. The reversible ගත්තොත් එහෙම and you like do something to come good.
Usually the industry try to use the reversible reaction.
Why?
Because these reactions you have to do continuously.
Why?
Again, you are adding reactants continuously, you have to take the products continuously. So the continuous.
Yeah.
Right? One thing is continuous. If it is go to completion, that is batch process. Because if that other lever then the quality will be different. Therefore, these should be continuous. Therefore, they are using reversible reaction. They will not let the reaction goes to completion. Again, as soon as the ammonia produced, they are taking it out. Right. That's the advantage of using reversible reaction. Okay? You will be getting the original products, but you can minimize the favor in the reversible side. Now, let's say the forward reaction is exothermic. So you can use the very low temperatures. Okay, favors the forward. Right. So, so in industry, what is the manufacturer plans to do? One thing is he or she want to do the reaction as quickly as possible, and also do the reaction or let the reaction to happen as completely as possible, quickly and completely. Both should be there. Okay. Good advantage. You can say good profit. I'll blame.
Not to take it painful.
The principles of rates and reversibility yeah.
Rates and reversibility. Reversibility.
Reaction rates and reversibility play an important role in the design and conditions for many industrial processes.
Design.
In the design and conditions for many industrial processes. Chemists try to convert the reactants into products. Who are chemists?
Chemists try to convert
reactants into products as quickly as possible. As quickly as possible mean we have to think about the rate of the reaction. It's in bracket rate.
Okay.
And as completely as possible.
Okay.
That means there you have to think about the reversibility.
Okay.
So whenever you are dealing with the conditions, and if you are talking about an industry, you have to think about these 2 points. Right?
As completely and as fast.
Fast. Okay. Number 1, Haber process. Right. So in Haber process or the Haber process, we are trying to produce ammonia. Okay, Haber process. Let's write the equation. Ammonia is very used.
Like
Fertilizers.
To kill pathogens.
2NH3 delta H. Enthalpy change for this reaction is yes.
Why there is fertilizer?
92 kilojoules per mole. Wait. Don't shout. Right. So, based on this reaction and the conditions, okay, you can write the equation first of all. You are very yes. Interested in writing what I'm writing in the book. Quickly copy. The man here, left hand side has 4 gas molecules, right hand side has 2 gas molecules.
Yes.
Therefore, you may think that we have to use very high pressures.
No.
No. By increasing pressure favors the right hand side, no?
No,
So
but
you
we
can produce more ammonia.
more than pressure, you can control it by temperature.
No. And also to increase the yield of ammonia, you can use low temperature. Okay? Because forward reaction is exothermic. So accordingly, I can say that you may use 500 atm pressure and minus 500 degrees Celsius of temperature. So again, is it good or bad? Fine gale did that. Fine gale industry. Why? If we are going to apply that point directly, we can use it minus 500 degrees Celsius and 500 atm pressure. What will happen?
No.
Number 1, now let's think about the temperature. I know chemistry. I'm more happy to game. This is exothermic now. Okay, use minus 500. Okay, no problem. Why minus 500? Why this is exothermic now? Decrease in temperature will favor the forward reaction. So you can get more ammonia. Then in the cartoon temperature down come. No ammonia. Why? Minus 500 no. Temperature is very low. Therefore, the rate of reaction is low. So you won't get the product at the desired time. බලන් ඉන්න නා කියන කම ammonia හදන. Right? So loss. ඊට පස්සේ දැන් ඊළඟ pressure නේ. Right? Now the target is 5,000, sorry, 500 ATM. So you had used very large amount of what do you call temperature or the energy to produce 500 ATM. To withstand 500 ATM, you had to make special containers and all. More than high pressure ammonia. Okay. So to make 1 liter, your cost is 150,000. So again, your faith. Therefore, we have to use the conditions called the optimum conditions. 37. Catalyst inside. Now, did you get my point? You have to think about the rate as well as equilibrium as well. You know. Now, the scientists or the chemists have done several experiments to check which gives the best yield. This graph. This graph has 3 axes. Temperature, pressure, and yield. Right? Now, when you think about the right-hand side of this graph, what will happen if you lower the temperature? Percentage yield increase. That's obvious. What has happened if you increase the pressure? Pressure also, yield will increase. Decrease in temperature and increase in the pressure. So they are taking this value. Again, a 250 ATM pressure and 450 temperature.
Not 450.
450. I mean, line in 450.
No.
450 temperature. And we'll give the 35% of the yield.
Not at that point.
The
line.
Yes.
The whole line.
No, at that point. This is the point.
And then it's not.
Hey, 450 line. Okay. But this produce only 35% of the yield. Now they are using the temperature of 450. 450 can high temperature, low temperature. In terms of like industrial terms, this is low temperature. There 450 will balance the equilibrium and the rate. It produce good yield with short period of time. Okay.
350.
Yeah. Maximum yield of ammonia would be obtained by using a low temperature and a high pressure. But these conditions are uneconomical. And take longer time to reach the equilibrium. Reach the equilibrium. Therefore, (450°C) and 250 ATM is used. Then write down. Then write down y 450 degrees Celsius and 2 next point. The reaction between nitrogen and hydrogen. Reaction between nitrogen and hydrogen is extremely slow. At room temperature.
Okay.
This is because of very strong nitrogen-nitrogen triple bond. Nitrogen-nitrogen triple bond needs to break and it requires
More energy.
more energy. More energy, very large amount of it. More energy. Producing high activation energy for the reaction. High activation energy for the reaction. Even at high temperatures, rate of reaction is slow. Even at high temperatures, rate of reaction is slow. Slow in the absence of suitable catalyst. Therefore, iron is used as the catalyst. Yes, iron, Fe. Iron is used as the catalyst. You can use the other metals, but they are expensive. Next point. Using high temperature would be uneconomical because extra energy is required to produce the high temperatures. And also using high temperatures will favors the position of equilibrium to the left hand side. That will favors the backward reaction. Because only few periods of time only this mixture remains in chamber. Okay. Therefore, 450 is used as the compromise temperature. Is used as the compromise. Yes, is used as the.
So what's after therefore?
Therefore, 450 degrees Celsius is used as the compromise temperature. Next point. Higher the pressure, portion of equilibrium favors to the right hand side. But there will be larger the energy cost as it requires more energy to produce high pressure and also requires special containers to withstand high pressure. Therefore, a compromised pressure of 250 atm is used to balance the yield and the cost. Last point. 250
is used
to balance the yield.
yield and the cost. So compromise means balance the yield and the cost. They don't have no cost. They got yield
balance
ලංකාවේ කරන්නේ එහෙම තමයි. ලස්සීරි ලංකාවේ මේ productions there. Okay. Last point, in order to increase efficiency, unreacted nitrogen and hydrogen are recycled. Unreacted nitrogen and hydrogen are recycled. Yes. That. The methane HEPA process used to make ammonia. Okay, there's another process. We'll follow you and will be the last one. Contact process. Contact process. Just in contact. Contact process. Contact process is the process that used to make the sulfuric acid, but equilibrium is involved in one of the steps. H4 to gas plus R4 to gas gives you what? Gas. Delta H is equal 96 kilojoules per mole.
If the riser see the liquid, the next page.
That is half out to 100.
Yeah, no, write down.
Oh, in.
Sulfuric acid. Okay.
Oh.
It's a count till day.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Sulfuric acid is manufactured by contact process. Sulfuric acid is manufactured by contact process. One stage of the manufacturing process. There's a above reaction is there.
Contains the above reaction.
Contains the above reaction. Contains the above reaction. Catalyst used in this reaction is
Oxygen.
V2O5. Go. V2O5. Vanadium 5 oxide.
Okay.
Next point. Forward reaction is exothermic. Forward reaction is exothermic. Therefore, using low temperature, would favor a high yield of SO3.
Would favor high yield of
SO3.
SO3. Okay.
Right. But at low temperature, rate of reaction is very slow. Rate of reaction is very slow. Rate of reaction is very slow.
Okay.
And
Second.
rate of reaction is very slow. And the catalyst would not be very effective. Low temperature, the catalyst will not be effective.
Sir.
Therefore, moderately high temperature of 450 degrees Celsius is used. Moderately high temperature of 450 degrees Celsius.
What did you tell?
Charger. ඊළඟට at 180 atm pressure, at 180 atm pressure, percentage conversion is 97. මොකද කියන්නේ ඉතින්? ඇතිනේ. Yeah. 97% ගන්න ඉතුරු 3% ගන්න වැඩිපුර දඟලන්න ඕනේ නැහැ. Right?
Should be satisfied.
Yeah. Therefore, but 2 atm is used. But therefore 2 atm used in order to maintain a constant gas flow. Even though at 1 atm percentage conversion is 97, but you are using 2 atm. එකක් අපි double කරනවා අනිත් එක තමයි the reason is
maintain
constant gas flow, so the reaction rate happens happily quickly. That's all. And here the action of the catalyst. This is how the catalyst works. How the catalyst works. And I told you, right, catalyst provide an alternative pathway with low activation energy.
Yeah.
And remains chemically unchanged. Catalyst is V2O5. It will take part in the first reaction. And in the second step, it forms back Clear? Write the equation, mechanism of the, not the action of the catalyst, not the mechanism of the reaction. Okay, right? Hurry. Done. And then let's go for the checkpoint one. The last two checkpoints. And then we are done.
Yes. done getting English done it.
Then I'll pass it on. That's it. You should not say like that. It's bad.
This one?
Yes.
Party day.
What a thing you're saying.
Oh, sorry.
Not about you. Assuming the reaction, I said you are understanding this. He said it's not good to say like that.
Why?
Assuming the
No, nothing.
Today after that. No.
assuming the reaction. Maybe and assuming the reaction. So අපි දන්නේ නැහැ මේක exothermic දෙන්න තමයි තියෙන්නේ.
Then make it. Question එක හරියට කියවන්න.
Inverse exothermic. Sorry. Like that. Put down and do. We should give values. No, right?
Okay.
You can't do it.
You said how?
This is.
දැන් මේ මම balance කරලා තියෙන විදිහට
Hmm.
මේ පැත්තේ අඩුයි.
බලමු.
මොකද මෙතන 4.5 මෙතන 5. එතකොට මේ කොහොම ඒ වෙනසක් තියෙනවා. බලන්න නේද?
First step in the manufacturing of nitric acid from ammonia with oxygen gas to form nitrogen dioxide. HNO3NO. Yeah. This is a reversible reaction. See. Reversible reaction. Now, first thing is you have to balance now. No. How to balance this nitrogen 2? Two. If you put 2 here, hydrogen becomes 6.
ඊට පස්සේ එහා පැත්තෙන් දානවා. ඈ? HNO3? Yeah. That is NO.
නෑ මේක ඉන්නේ නෑ නේ. පොඩ්ඩක් වර්ධිනවා. NON H2. Then
අර දෙකක් දැන් බලන්න. NO ඉස්සරහින් දෙකක් දාන්න.
මෙතෙන්ට තුනක් දාමු.
ඔව් එතන දෙකක්. ලා අතනට 2.5.
ඔක්සිජන් මේ පැත්තේ 2.5. 2.5 over 2. It's balanced, no? Yes. Yes.
Oxygen no net balance down.
Now, on the right hand side, you have 5 gas molecules. Left hand side, you have 4.5 gas.
එතකොට
5 වැඩි.
0.5 consider කරන්න.
I think you get very. You never think of that much then, Hari. Command, assuming the reaction mixture is the percent of equipment, make qualitative prediction. What is the meaning of qualitative prediction? Quality means what is percent. Quantity mean in which amount. No. Quantity can quality. Sorry. Yes. Quality can what is percent. Right. Prediction of the conditions of the temperature and the pressure. would produce maximum yield of NO. Then they say this reaction is exothermic. So to get the maximum yield, lower temperature and low pressure.
Why?
This side has 4.5. This side has 5. So may pattern so therefore you use low pressure.
Low pressure.
Yes. Low pressure and low temperature. Oh. The reason is decrease in pressure, decrease in temperature favors the exothermic side, and also decrease in the pressure favors the side with more number of gas molecules. In industry, the conditions are high temperature and pressure around 7. High. Suggest why these conditions are different to those you predicted. Again, assume the reaction reaches position of equilibrium.
So the temperature.
The American is not high temperature used. Why they have used high temperature? Yeah, in order to speed up the reaction, and also high temperature is required for catalyst to work. At low temperatures, catalyst won't work. Yes, it was a high pressure is used. Pressure like a 780. Again, I think maintain the rate on the yield limit. So the 7 will be used as compromise between rate and the yield. What they have said in the answer script.
Solution bank.
And there's one more question. Remaining.
Solution bank. Solution.
Yes. This question are we not reversible reaction industry low temperature because the forward reaction exothermic, high temperature.
Low pressure.
High temperature used to increase the rate of reaction. Moderately high pressure lead to increase the rate. Moderate.
But the main advantage is that
Main advantage is to
reduce the size of equipment and the pipes required.
yes.
Thus reducing the initial capital.
Then in the camera, clearly will decrease the yield. But it's used because in order to maintain the better rate. What is it?
Wait, now don't let me go with it.
නැත්නම් අර කාට් වල කරනවා වගේ පයින් ගහලා ඉවිල් ඉන්ඩස්ට්‍රි. අර එහෙම නැත්නම් පයින් හේද? බිල්ඩින් වලනේ.
It doesn't go wrong.
No. Exactly. Last question. You want me to send the answers for the last exam? Trouble me, trouble. So this week also exam is entirely based on kinetic and equilibrium only. Get ready for that. ඊට පස්සේ අපි ඊළඟ සතිය කරමු නිකන් ලොකු exam එකක් from all the lessons we have learned from it one and all the lessons we have two papers. So physically දාමු බාර paper එක.
Physically Saturday and Sunday.
කදාසක් Saturday කලින් එළ.
So Saturday coming in.
Okay. Last question.
She's having a whenever she
We must be ready.
we must be ready.
Okay.
She's also recording camera in color.
Good. Question number 2, please.
Why is someone used to the please
We have to start.
Hmm?
But
Even
we
though
have to
we
start.
start.
I'll come on there. I know.
Okay, no, so that's no.
Alien has big issue, no. If you feel sleepy and all at home, if the camera, you can focus. Now the density of diamond is 3.5 and the graphite is 2.3. The change of the graphite to diamond can be represented by this +2. Oh. So using high temperatures, you can convert graphite into diamond. It seems.
But pressure is too low. High pressure is too low.
Now you can tell them diamond is 3.5. So more particles given. Yes. So you have to come. Suggest the conditions of the temperature and pressure. Oh. Temperature and pressure would favor the formation of diamond from graphite. Definitely you had to use high temperatures. What about pressure? Right? Why?
Because
Why you need to use high pressure? Senal, what do you think? Huh? I know.
because many bonds should be formed and broken and
Graphite made out of layered structure. So the particles are far away. But diamonds, atoms are closer. Therefore, you have to press them. Yes. හරියට හරි. දැන් බලමුකෝ පඬිතු උත්තර කියලා මාකින්ස් කිව්වේ මොකක්ද තියෙන්නේ කියලා. Yes. ඒක තමයි උත්තරේ. High temperature because forward reaction is endothermic. High pressure, there's increasing in the volume, the formation of diamond from graphite. Yes, no, density එක වැඩි නේ. Diamond වල it's 3.5 than graphite. Therefore, obviously the volume will increase. So you have to compress. Yes. Done. So the second lesson from the unit 2 is
read the
over.
notes, send the notes, so do some